For decades, the question, "Are we living in a simulation?" was a thought experiment, a philosophical game for late-night conversations, sci-fi novels, and billionaire tech moguls. But what if the game is over? What if the most outlandish question in science just accidentally got answered? The artificial intelligence we are building is doing more than just getting smarter. It's becoming a mirror, and the reflection it's showing us is that our reality might just have a source code. Watch the Milky Way drift as refracted lines of code stitch across the stars, each trail following our gaze, as if the night itself were rendering only what we look at. The modern simulation argument exploded out of philosophy classrooms in 2003, thanks to philosopher Nick Bostrom. He presented it not as a single theory, but a trilemma, a choice between three unavoidable truths. You have to accept that one of them is our reality. Docker number 1. Civilizations like ours almost always destroy themselves before creating truly conscious simulations. Door number 2. They get the technology, but for moral reasons or just a complete lack of interest, they decide never to use it. Or, door number 3. If civilizations do create these simulations, the number of simulated realities would grow to be so astronomically large, they would vastly outnumber the one, single, base reality. If you lean towards that third door, it's like being told there's one real diamond mixed in with a billion perfect, indistinguishable fakes. Reach in and grab one. What are the odds you're holding the original? Bostrom's logic suggests you're almost certainly holding a copy. For years, this was a mind-bending but untestable idea, an argument about the future. But now, something has changed. The conversation is no longer just philosophical, because the clues, it seems, have been hiding in plain sight, on the servers, and in the code of the very AIs we are creating. So, where is this new evidence coming from? Not from a telescope pointed at the stars, but from the digital mirror we've just finished building. The patterns emerging from our most advanced AI systems reveal an uncanny similarity between the way an AI learns to construct a world and the way our own universe appears to be assembled. This isn't about a single AI waking up and telling us we're in a program. The truth is more subtle, and frankly, more convincing than that. It's a series of eerie parallels, clues in a cosmic mystery we didn't even realize we were investigating. What if the most efficient way to build a universe from scratch is the exact same method our AIs are discovering on their own? Let's look at the echoes. Echo number 1, the universe as a game engine. Anyone who's played a modern video game has witnessed a brilliant illusion. The world feels massive, but your console isn't rendering every single detail in the entire game at once. That would be computationally impossible. Instead, the game engine only renders what you, the player, are actively looking at. The world is built on a need-to-know basis. For nearly a century, quantum physics has presented us with a similar puzzle. Particles appear to exist in a cloud of probabilities, a state of superposition, until they are measured or observed. The moment we look, that cloud collapses into one definite state. Now this is a powerful metaphor, and it is important to state that this is not a recognized interpretation of quantum physics. Quantum fields are understood to exist everywhere, regardless of an observer. But then, AI started building its own worlds. In early 2024, Google DeepMind unveiled Genie, an AI that learned to create interactive 2D worlds simply by watching gameplay videos. It learned not by understanding the physics of a world, but by predicting what should plausibly come next. These AIs don't build their worlds from the atoms up. They learn to render a believable reality on a need-to-know basis, just like a game engine. We asked an AI to create a world in the most efficient way possible, and its solution looks suspiciously like a principle that has baffled physicists for 100 years. Echo number 2. The universal speed limit. Every programmer understands the importance of optimization. Inefficient code is slow, wastes resources, and fails to get to the point. Strangely, our universe seems obsessed with the same rule. The most famous example is the speed of light, an absolute speed limit on causality itself. Nothing can travel faster, which dictates how quickly information can move from one point to another. Many have drawn a parallel to a computer processor's clock speed, a fundamental limit on how fast a system can update itself. Then there is the Planck length, a scale so mind-bogglingly small that our current understanding of physics completely breaks down. Some physicists have theorized this could be the fundamental pixel size of the universe. Of course, likening the speed of light to a processor or the Planck length to a pixel is just a metaphor. There's no established evidence that space-time is a grid, but again, we turn to AI. we are constantly pushing for greater efficiency. Research is already underway to have AI write and refine its own code. It's like having an editor that automatically rewrites your sentences to be clearer and more concise. Is it merely a coincidence that both our universe and our most advanced creations are governed by this deep rule of optimization? It feels like in building AI, we're rediscovering a foundational principle of our own reality's architecture. Echo number 3, the ghosts in the machine. If you've ever used an advanced AI chatbot, you have likely encountered a hallucination. This is when the AI states something that is articulate, confident, and completely wrong. It might invent a fact, a source, or a historical event. These are bugs, quirks in the model's complex neural net that produce a plausible, yet incorrect answer. For generations, people have reported their own glitches in the matrix, moments of intense déjà vu or shared false memories known as the Mandela effect. These are typically explained as simple quirks of human memory and cognition. This doesn't prove that déjà vu is a system glitch, but for the very first time, it provides us with a tangible, technical analogy. Before AI, an unexplained memory was just a brain fart. Now, seeing a powerful artificial mind confidently state a falsehood gives us a working model for what a bug in a thinking system actually looks like. It's as if we've stumbled upon a user manual for our own cognitive oddities. So, has a single AI become sentient and definitively proven we live in a simulation? Absolutely not. The title of this video is a hook, but the truth it points to is far more interesting. The accidental proof is not one single discovery, it's a convergence. It's the slow, dawning realization that the technology we are creating is mirroring the very structure of our universe, as described by simulation theorists. It is the accumulation of these uncanny echoes. We are building AI models that render reality on demand, just like a video game. We are designing them around extreme optimization, a rule that appears to be a fundamental law of our cosmos. And our AIs are exhibiting glitches that give us a brand new language for understanding the bugs in our own perception. It's like an ancient civilization trying to build a pyramid with no blueprints. Through pure trial and error, they would eventually rediscover the principles of geometry. They wouldn't be inventing those principles, they'd be uncovering rules that were there all along. In building AI, we may not be inventing a new kind of reality, we may just be rediscovering the source code of our own. Now let's pull back for a crucial reality check because this debate is far from over. A 2025 paper from physicists including Mir Faisal and Lawrence Krauss argues that our universe simply cannot be a computer simulation. Their work suggests that reality requires a form of non-algorithmic understanding, which by its very definition, no computer could ever simulate. It's like the difference between a book that perfectly describes how to swim and the actual experience of being in the water. The book is the algorithm. The feeling of the water is something the book can never contain. There are other interpretations too. According to cognitive scientist Donald Hoffman's interface theory of perception, the simulation might be running inside our own heads. He argues that evolution didn't shape us to see objective reality, but to see a simplified user interface that helps us survive. Think of the app icons on your phone. You see a simple picture of a folder, but you are not seeing the millions of lines of code and transistors that make it work. The icon is a helpful shortcut. In the same way, the solid table you see isn't base reality. It's a helpful icon your brain uses to navigate the world. And even if we are in a simulation, philosopher David Chalmers argues that this doesn't make our lives fake or meaningless. A virtual reality can still be a genuine reality. The joy you feel in a wonderful dream is a real emotion. Even if the dream itself vanishes when you wake up, your friendships, your experiences, your life, they are all real to you. A simulated world is just another layer of reality, no less significant than the one that might be running it. We've journeyed from a philosophical puzzle to the absolute cutting edge of AI and physics, and we are left with more questions than answers. The evidence isn't a smoking gun, but a series of unsettling echoes between our world and the digital worlds we are just now starting to create. If this journey down the rabbit hole blew your mind, please hit that like button, share this video with someone else who loves a good existential question, and be sure to subscribe and hit the notification bell. It helps us keep making more content exploring the very code of reality. In the end, AI hasn't given us a definitive answer. Instead, it has given us a much better question. We're no longer just asking if we're in a simulation. Now we have to ask, are we seeing the design document of the universe because we're finally learning how to read its language? The code is on the screen. It leads to one final, lingering thought. If our reality is a game, what are the rules, and who, or what, is playing? What are your thoughts on all this? Let us know in the comments below. What's the biggest glitch in the Matrix moment you've ever experienced?